One application of separable differential equations dealing with what are called mixture problems. This is when you're adding to a fixed tank, or it could be some other type of container, which has a fixed amount of some, let's say, liquid, could be water, or it could even be blood if we're talking about adding drugs into a bloodstream, or other types of liquids, where we're adding to this tank a mixture which has a certain percentage of a chemical being added to the tank. Let's say we're adding a mixture of water mixed with salt, so like a brine solution is being added to the tank, or like we're saying, you could be injecting a certain drug into the bloodstream, would be another type of application. And then we're seeing, okay, after so much time, how much of the thing that we're adding, like the salt or the drug, is within the bloodstream or tank. So let's look at an example where at time equals to 0, a tank contains, let's say, 4 pounds of salt dissolved in 100 gallons of water. Suppose that a brine solution containing 2 pounds of salt per gallon of water is allowed to enter the tank at a rate of 5 gallons per minute, and that the mixture solution is drained from the tank at the same rate. Find the amount of the salt in the tank after 10 minutes. Okay, so to be able to do that, we've had to find a function that represents the amount of salt in the tank. So let's call that y of t for now. And now it's going to be a variable will be t for time, because we do talk about per minute. So we're saying y of t is going to be the amount of salt in the tank after t minutes. Okay. Now, we don't really know too much about y of t, except we know about the rates. So that's how we're going to end up with what is called a differential equation. Now, a differential equation is an equation which involves the derivative of functions. So we do know that for dy dt, the change in rate of the salt over time, what it is equal to is the rate coming in minus the rate going out. Now, for the rate coming in, we do know that there's 2 pounds of salt per gallon of water is being allowed into the tank at a rate of 5 gallons per minute. So we do know for the coming in, we have 2 pounds per gallon is coming in at a rate of 5 gallons per minute. So that would give us the number of pounds coming in per minute, which is what we're trying to figure out, the amount of salt per minute. So that's the rate of it coming in. Now for the rate going out, we do know that it's leaving at a rate of 5 gallons per minute, because it's drained from the rate at this from the tank at the same rate. But for the amount of salt that's going out, it's the amount of salt that's currently in there divided by 100, because we have 100 gallons. And that would be in pounds per gallon. Because the y of t divided by 100, that's the amount of salt per that 100 gallons. And again, it's leaving at a rate of 5 gallons per minute. So what this tells us is that dy dt is equal to 10, because we have the 10 pounds per minute, minus, and then the y of t over 100 times 5, this would equal to 1 over 20 y. So this is where we know y is a function of t. So this is our differential equation that we have so far. I'm going to simplify this a little, just subtracting these two terms by finding the common denominator. So for the first term, I'd multiply top and bottom by 20. So this would be 200 over 20 minus y over 20. So that would be 200 minus y all over 20. So again, this is our differential equation. dy dt is equal to 200 minus y all over 20. And now we're going to use the method of separation of the variables. So we multiply both sides by dt, divide both sides by the 200 minus y. So this will be 1 over 200 minus y dy is equal to 1 over 20 dt. And then what we do next is, once we've separated the variables, we'd integrate each side. So we'd have the integral of the 1 over 200 minus y dy is equal to the integral of 1 over 20 dt. So integrating each side with respect to their respective variables. So integrating the left side with respect to y, what you could do if you have 1 over 200 minus y dy, so if we let's say u equal to that 200 minus y, then du would equal to negative dy. So we multiply the inside by negative, the outside by negative, and so this becomes negative the integral of 1 over u du. And the integral of 1 over u would be the natural log of the absolute value of u. So what this gives us is negative the natural log of that 200 minus y. And then on the right hand side, the integral of the 1 over 20 dt with respect to t, that'll be 1 over 20 t plus some constant c. We only need one of them because if we had c on the other side, if we subtract that different constant from both sides, then we'd still have some constant. Okay, so we have the negative natural log of the absolute value of 200 minus y equals to 1 over 20 t plus c. I'm going to multiply both sides by negative 1 to get the negative on the right hand side. So we'd have the natural log of the absolute value of 200 minus y equals to negative 1 over 20 t. Then I could still just say plus some constant c, because if c is a constant, the negative c is still just a constant. Okay, if we're solving now this logarithmic equation, so we have the single log equal to this expression on the right hand side. This would be the same thing as e raised to the natural log of the absolute value of 200 minus y equals e to the negative 1 over 20 t plus c. Now for that right hand side, if you have e to the natural log of anything, that's just equal to what's inside the natural log. So this will just be the natural log, this will just be the absolute value of the 200 minus y. And then on the right side, we're going to use the property of exponentials that we learned some time ago, like let's say in beginning our intermediate algebra, that if you have an exponent or a base raised to, let's say, raised to the n times another raised to the m, or a to the m, then this is equal to a to the n plus m. And this goes both ways. So if you have a base raised to n plus m, that's the same thing as a to the n times a to the m. So this would be equal to e to the negative 1 over 20t times e to the c. Well, c is a constant, so e, which is that number 2.718 ... e to the c is just going to be some constant. So this will just be times some constant, which again we're just going to call it c. Now, since that constant could be positive or negative, that we could drop these absolute value signs and just write this as 200 minus y equals to c times e to the negative 1 over 20t. Because again, if it's positive, then this c is a positive. If it's negative, then this c is a negative. And now remember, we're trying to solve for what y is. So we We could add y to both sides, subtract this c times e to the negative 1 over 20t. So you get y of t, or y, is equal to 200 minus c e to the negative 1 over 20t. So this function here gives the amount of salt at time t. So give you the salt in pounds at t after t minutes. So first that's the function. Now we still need to solve for what c is because we're trying to find the amount after 10 minutes. So we got to first solve for what is this constant c. Now to do that, we're going to use the information that, remember, initially we do know that it contained 4 pounds of salt dissolved in this 100 gallons. So we do know when t equals to 0, y, the amount of salt, was 4. And we're going to use that to solve for what is our c. So y of 0 is 4, which is that 200 minus c e to the negative 1 over 20 times 0. Negative 1 over 20 times 0 is 0. E to the 0, that's 1. So this gives us 4 equals to 200 minus c. Add c to both sides, subtract 4 from both sides. We get that c equals to 196. So this tells us that our function that gives us the amount of salt at time t is 200 minus 196 times e to the negative 1 over 20t. Now one thing at this step here, where we have the 200 minus c e to the negative 1 over 20t, some books might have said you could have a plus c, because again c is some constant. And then when you solve for what c would be, you would get negative 196 or you get the minus 196. So you'd get the same answer either way you go about doing it. Okay, and now to answer the question, it was, remember, find the amount of salt in the tank after 10 minutes. So we plug in t equals to 10. So y, when t is 10, that'll be 200 minus 196 e to the negative 1 over 20 times 10. So that'll be 200 minus 196 times e to the negative 1/2. And then this is just plugging this into your calculator. And what you would get this to be about is 81.199 dot dot dot. So there would be about 81.1 pounds of salt in the tank after 10 minutes. Now, I also want to show you, okay, with our function, this 200 minus 196 e to the negative 1 over 20t, what does the graph of that look like? And the graph of that looks like this. It's this exponential function. And you would see that as time goes by, what will happen is the amount of salt, the y values, will get closer and closer to 200. Because that would make sense, because eventually the percentage of salt for the tank will become like the amount that we're adding into it, which is that it was 2 pounds of salt per gallon. So if we had 100 gallons, then it would be approaching to 200 pounds of salt. So that's what the graph of that would look like. And then we could see also, like we said, when t was 10, it was about 81.12 pounds of salt.